Idly ho, students. Mr. Kaczynski with you. We've got the first standard here, the first 11 questions of the Chapter 4 test. And let's get right after it. You can take some notes and possibly be eligible for a retake if needed, or maybe you just want to see what you did wrong. Here we go. For problems 1 through 3, tell whether each table represents a function. It's just a simple yes or no, but we'll give it a little bit of explanation as well. So the first thing my eyes are drawn to here is that at the input 3 appears twice. However, both times its output is 7, and every other input obviously only has one output. So that makes this a function. All right, so we'll say, yes, this is a function. Each input only has one output. Even though 3 appears twice, its output is 7 both times. Okay, next up. Got our x's and got our y's. See, I don't even ever see any of the inputs repeating. So that's going to be an obvious yes. We don't have enough to go on. You know, I guess maybe some people might be drawn to this idea, though, that both -3 and +3 have the same outputs. Both -2 and +2 have the same outputs. -1 and 1 both have the same outputs, but regardless, this is still a function. How about this? Even though some inputs share an output, they all have exactly one output. All right, and then on this third one, we do see an issue right away, okay? The input 2 has 2 different outputs, so this is going to be a big fat no. So we'll say the input 2 has 2 different outputs. That's a counterexample proving that this is not a function. Susan made up the following coding rule. Take each letter of the alphabet and advance it 5 letters. Does this rule describe a function? Well, yes. Each input will always have the same output. It's definitely a function. A is always going to be coded as A, B, C, D, E. A is always going to be coded as E, I assume, maybe F. Doesn't really matter. It's always going to be coded the same. All right, more function stuff. Which graph shows a relation that has a domain of -3 to 5 and a range of -3 to 4? The x value -1 corresponds with the y value -1, and it is a function. So it's a lot of criteria. I guess I would start. Let's start with is a function. All right, well, I can see that that's not a function because it doesn't pass the vertical line test right here. Okay, this is not a function because it doesn't pass the vertical line test right there. So that leaves these two. And this is the only one that includes the point -1, -1. So it's got to be that one. Let's check its domain. It goes from -3 to 5. Here's -3. And 1, 2, 3, 4, 5. Yep. And its range is from -2 to +4. I'm sorry, -3 to +4. Yeah, so here's -3, 1, 2, 3, 4. Yep, there's +4. So it's definitely choice D. That's a D. Which graph shows a relation? I better start this all over. Basically, almost the same criteria. It looks like the range is a little bit different, but the domain's from -3 to 5. The range is -2 to 4. It goes through the point -1, -1. It's not a function. All right, so this one is a function. This one is a function, so we're not going to choose that. And let's see. Both of these go through the point -1, 1, right there and right there. So which one's got the right domain and range? Domain of -3 to 5. That goes from -3 right there to 5. 1, 2, 3, 4, 5. Yep. And so that's the right domain. The range is from -2 to 4. -2, yeah. 1, 2, 3, 4 to 4. Looks like that's the one. Yep, this one goes from -3 to +1, 2, 3, 4, 5. So that's too big. So this one's choice A. Home stretch here on this first standard. Use the following graph to answer number 7 and 11. 7 through 11, the graph shows Darnell's energy level during the school day. When was his energy level the highest? So here's energy level being measured along this vertical axis. When was it the highest? Somewhere around here. So that looks like about 2 p.m. maybe. So, yep, choice D. Same graph, I just recopied it so I can draw on it again. When was this energy level rising the fastest? Well, I see it rising here. I also see it rising here. Which portion is the steepest though? I'd say this portion, like right in here. Okay, so maybe from 12 p.m. to 12:15 p.m. It does slow down after 12:15 p.m., so that makes sense. So that would be the answer choice. When is his energy level the lowest? Right there, it's pretty darn low, and it looks like it's a little bit lower than it was at 8. So we're talking 12 p.m. 12 p.m. right there. When is his energy level decreasing the slowest? Well, I see it decreasing right through here and right through here. So after 2 p.m., that's actually a pretty quick decrease. So it looks like it's barely decreasing at all right through here, but it is slightly going down. So that would be what, about halfway between 8 and 10 would be 9. So between 9 and 9:15, I'm going to say. And what is the dependent variable in this situation? Well, I guess we would say that energy level is dependent on time in this situation. Energy level is dependent on time. That makes energy level the dependent variable. All right. So that's standard 4A for the chapter 4 test. Hopefully you learned something from that, and I appreciate you guys taking the time to watch it. Have a good one.